morning, afternoon, wherever you are watching later on or here today. I hope you all get your daily coffee dose and are ready for the next talk in the schedule. Thanks again for coming here and learning a little bit about reactive integrations. Before I actually start introducing myself and starting the talk, I would like to know who actually is working with some kind of reactive technologies already. Just scream at me, I'm comparably interactive. What are we talking about? Alpakka or? A project reactor, yeah, I heard that. Anybody else? Vertex, of course, that's definitely missing. So a couple of people have a reasonable background about reactive technologies. Wonderful. Let's talk about myself a little bit. I'm Markus Eisele, came all the 1 hour and 5 minutes over from Munich to speak here. I do work for Lightbend as a developer advocate, so you see me speaking around the world more or less. Last year was a little bit more crazy than this year. And I think my first ever talk at GeeCON was 2015, if I'm not totally mistaken. So I'm very happy to actually be back here. I love those big screens. I've been doing a lot of work in my past, so you know that one doesn't even get born as a developer advocate, right? You actually have to work on something reasonable and do some software development before you do that. And I've been working as a principal architect for Fortune 500 companies around Germany, mostly automotive OEMs and financial industries. And I think some of the biggest systems I built a couple of years ago are still running as of today. And my main background is actually Java EE. So I have a solid legacy background. And when everybody started talking about microservices, I decided to look into technologies that are a way better fit to implement these kind of architectures. When I'm not speaking at wonderful conferences around the world, I actually also run my own conference. I'm the founder of JavaLand, so the one thing that is very different about JavaLand is it's not a cinema, it's actually a theme park. So there are roller coasters and stuff like that. Not during the day, but the first night is always open house, and there are a couple of attractions running. So whenever you want to combine a nice vacation with a bunch of roller coaster fun and learning, you're probably right at JavaLand. Give it a try. So, who is building a microservice-based architecture right now? That's only like, what, 20 hands, like 1/4 maybe. So, microservices are obviously around, and more companies are looking into how to implement these kind of architectures. And there are a bunch of challenges. And now everybody's talking about reactive. And everybody's talking about streaming. So let's start with a little bit of background where this whole stuff is coming from. I don't want to say mess, because, as I said, legacy, big monolithic applications used to be fine, right? I built some of the finest myself. So what's the reason that we actually have to work in that distributed world? I'm not saying mess. So this is a little bit of an insight into one of our reports and surveys we did with our customers. And we've been asking them, what are the biggest problems as of today when you look into your software development projects? So what's really hurting you? And as you can see, there are a couple of big blogs. Release frequency. Yes, we've learned about continuous deployment, continuous integration, way before we had microservices. Obviously still a thing. Yes, I've seen monolith being deployed once or twice a year, but that should be a thing of the past. Let me raise another question to you guys. Who's deploying monthly or faster or more often? Who's still deploying quarterly, half a year, and once a year? Or at least still 2 hands go up, yeah. So those are my favorites. Production setting times always has been 24th of December or the day before I actually went on vacation. Those have been my favorite production setting times. Yes, release frequency is obviously a big thing, but we could definitely reach that with a solid process. If it's a real tangled monolithic application, I might question that we can get like easy changes very quickly into production, right? So pain point, accepted. Developer velocity, whatever that is. Let me talk about that a little bit later. High infrastructure cost. So people are still forced, especially in Europe, especially the really, really conservative Germans, they want to have their plain bare metal in the basements. And yes, that's definitely a thing. That costs money, right? And if you just go out to AWS and pay what you actually use, that's a different thing. Probably not working in Germany. I don't know how it's here. Awful downtime, 10%. So Black Friday sales, whole online shopping revenue of a complete year generated in just a couple of months. I don't think this is very common in Europe, but we do have a couple of customers who actually experience that kind of setting. So whenever their sites got overwhelmed, the classical scaling architectures just didn't work anymore. Meeting demand. Okay, meeting demand is an interesting bubble. Who has seen that slide before? I still find that interesting because even mainstream media is starting to talk about this. So I have two wonderful daughters, 6 and 10 years old, and believe it or not, they started asking for mobile phones. They really want to be online. They really want to start contributing to that whole wonderful online world. Scares everything in me. But yeah, that's a good indicator, right? So this is showing you the number of connected users to the internet over the years. And I think I haven't updated it in a while, but there's a little URL to the right where you can actually get today's numbers. Whenever you find those teensy little URLs on my slides, this is what I consider homework for many reasons. First of all, I always thought I hate homework, which is totally not true since I have my girls in school. They hate homework way more than I ever did. And I thought it's a good way for you to actually give you a reason to rewatch this talk or look at the slides afterwards. Sometimes I just throw bullet points at you, and you get a chance to dive a little bit deeper into certain topics when you follow that like breadcrumb I leave for you on the slides. So more and more connected users. Connected things, like my teensy little Fitbit, still not connected, only via my phone, but Apple Watches with SIM cards in it, cars that are constantly connected and producing data. Speaking of data, the more connected devices and connected things we have, the more data actually exists in the world that we could probably operate on. So how did we operate on data in the past, even if it's been a chunk? Batch jobs, right? Batch windows. That's what made my weekends really, really, really short from time to time, especially when customers needed to crunch like invoice runs for insurances. Like the annual car insurance invoicing process, there was exactly one weekend to get like 1 million or millions of invoices out, and they needed to be processed. So those were the fancy batch windows. Is this something that we would even accept as of today when we're using an app and we're looking at some financial analysis of our account or transactions? That's something that needs to be done in real time. And there are more and more of these use cases that need to switch over from former batch processing and then those batch windows into the real-time world. So there's something that caught my eye, actually. I'm a little bit into cars. Of course, I'm German. And at one of the last big motor shows, one of the Ford executives actually talked about the amount of data that a reasonable 2017 car emits just while driving. Those are all bus architectures, like everything is connected to that central bus. Make a guess, how much is it, just by driving a reasonable 2017 Ford model? Per day. Good question, thank you. Time frame by day. Yeah, 10 times that much. So easily 20 gigabytes of data. And those are mostly like steering information for everything you want to see, right, and work in that car. What do we do with that data? Do we just leave it in the car? We can dump it like it's dumped today, like it's not stored mostly. There are a couple of like error codes that get locked internally. But just imagine this. I'm an awful fast German driver. I bought like a little Ford ST, which is 180 horsepower. It's a go-kart to drive on the streets. And as everybody knows in the whole world, Germany doesn't really have speeding limits, right? So it's a lot of fun to drive that thing. My wife is actually driving like, I don't want to say that, but you can imagine, right? She's very careful. She's always thinking about the kids. They could be sitting in the back seat, even if they don't. So it's, I'm driving most of the time, right? So we're both paying pretty much the same car insurance. Is that fair? Obviously not, right? She's way more careful than I am. She should pay half or less, or even maybe I should pay hers. I don't know, which I'm probably doing. But anyway, so just imagine those 20 gigabytes also contain some kind of location data. And the cars could keep sending GPS information together with map information back to the car companies, which start to share those data with the insurance companies. Thankfully, this scenario is not possible as of now because of data protection laws, but it would be an amazing use case to have, right? We could end up paying for what we use, that kind of cloud mantra. So the more dangerous, the faster you go, and this needs to take into account averages. Like, how fast can you go from A to B using a certain route, taking all the speed limits into account, and how fast did that guy actually go? So, and depending on that, creating a risk profile, does that sound like something you want to do for millions of drivers in a weekend batch window? Probably not. So we need that kind of data analysis in almost real time. And the only way to actually achieve that is to use a streaming approach while handling that data. Message, event-driven, whatever you want to call it. If you look back a little bit into history of what we built, coming all the way down from mainframes going into that app server world, I do believe that we all by now accepted that none of those technologies ever were designed to work with streaming data, at least not in the heart. So this is literally why microservices exist. To solve that big problem, to work with streaming data, to come out of that kind of asynchronous world, which is more or less built to solve package-wise processing. And if we put that into the cloud, probably across continents or various data centers, this whole thing is definitely not going to be easier, especially because there's another thing that many people do forget. Microservices projects, especially in enterprises, will very rarely be greenfield implementations. So there is a need to actually connect those back into existing legacy applications. Honestly, like off the records, when a company invested thousands of dollars into something that is doing a decent job, and they only have to solve one additional use case that might have that real-time processing requirements, they're not going to throw everything away and rebuild it. So there'll always be integration. Bottom line, quite simple equation. More users, more data, more systems leads to way more connections than we actually have as of today. And the fun part here is, it's actually just about scaling this thing, this most common programming task that we all did in the past, right? I mean, we take some input, transform it according to rules or regulations, and generate output. So the only thing that we need to make sure is that this thing does not only scale to distributed cloud workloads, but it also scales in a highly asynchronous world that handles streams. Does that kind of sound familiar, like integration and enterprise requirements? Isn't that just what we know since ages. Who has read that book? Just because I'm curious. 5, 10. Yeah, it's millions of years old, right? Even I've read it. So yeah, it's just integration, isn't it? Maybe not. Isn't that what we tried to achieve with SOA already? Like many endpoints, many systems, web services schemas, problems around service discovery. Is anybody, does anybody still have to work with an ESB? Like especially one of those big legacy projects? Not talking Kafka, right? So more like Aqualogic Service Bus or IBM WebSphere integration. Seriously, nobody anymore? Hey, that died fast. Just one. Okay, 2. Oh, you're afraid? Don't be afraid. It's okay. It's a legacy. It will always be there. And funny enough, I've worked on many of those projects, and we always managed to kind of make it work. And we learned our lessons over time. We started like scaling those ESBs, and we actually started like to cascade them a little bit and create like business domains. So you can make that work. It just takes a lot of processes, right? And it will definitely never be the most performant application you've ever seen. So yeah, ESBs kind of weren't the solution. And one big issue with ESBs, and I'm not saying it's been the only one, but it's been one of them, is that whole discussion around synchronous versus asynchronous processing. And especially in the Java EE world, most of the APIs are only optimized, and I believe it's historical, right? I mean, I'm not blaming anybody. I'm not saying you've always knew it would be awful to use that kind of technology. Historically built on a threading model, on a synchronous threading model. So there's no real way of actually spreading workloads out to other threads while having the main thread blocked with an HTTP request. Yes, fork join, yeah, many other things. You can implement threading yourself. There are nice pooling concepts in various application services that you could use. But this whole thing was never something that we used. I never used it. Even as an architect, we tried to optimize performance afterwards by creating and assigning various execution pools. But whenever somebody was asked to actually implement a fully threaded system, I turned around and ran as fast as I could. So far, so good. So there are some kind of approaches in Java EE. Don't get me wrong. Not even in Java EE, also in the JDK, actually. So we all know input stream and output stream. Simple question. Can I pipe an input stream into an output stream? Well, make a guess. Who says yes? 3, 4, 5. Who says no? A little more, 10. And the rest is undecided or JavaScript programmer? Good luck with that. So no, you can't. Obviously not. It's not the same stream, and you can't just pipe them into each other. Even it would make sense, right? Take some stream, process it, put it into an output world, right? So Neo channels. We do have something called a read listener and a write listener in the servlet specification. Same concept, same problems. You can't just read something, pipe it, and write it. JDBC, yeah, you can read on your own. There are some very partial solutions, but it's not coherent, and it definitely not covers the complete Java EE stack. Should I start saying Jakarta EE? No, I won't, but yeah. If we just start to make that even a little bit more complicated at that point, so not looking at that one fancy Spring Boot microservices that you build on that Java EE stack that is inherently synchronous and you never heard about Project Reactor before, let's start adding some more integration to it and putting a couple of services left and right with possibly a synchronous boundary, so you don't know how long those actually will run and you can't wait for an answer because you want that to be asynchronous. And further on, assume that those services actually have a different capability in actually processing events, messages that are being sent to them. Service A is producing 10 messages per second, for example. Service C ultimately only consumes 1 message per second. So what's the outcome of that kind of design? What happens? Scream at me, wake up, come on. I like my talks interactive. You don't. Okay, fair enough. Yes, Java, out-of-memory exception. That's best that could happen, right? So we're overloading one service. Yeah, you could throw hardware at the problem, for sure, to a certain extent. But even that probably won't work. We need something else. Suggestions? No, that's why I'm here to tell you, right? So, queuing, obviously, that's been the synchronous solution, right? Putting him in a queue and hoping that everything will work, or persisting that queue to make sure none of them get lost, right? So, it's way easier to actually add flow control into the whole game. So, what does that mean? For now, with all the classical architectures that we've seen, we've been trying to control data flow into one direction. If we add back pressure to it, a little bit more flow control, we could also let components talk to each other, not into the direction the data is flowing, but the opposite direction. So if component A, service A, whatever you call it, sends more messages to C or B than they can consume, they can talk back to service A and tell them, don't send me any more, I'm overloaded already. So that gives a very good sense of scaling and makes sure that no individual services are overloaded. So what we're now looking for is a stream library implementation that can handle exactly that kind of back pressure. And believe it or not, the solution is pretty simple because it's been out there since many, many years already, and that's Akka. Anybody, I've asked that before, like I've not explicitly asked for Akka users. Anybody here? 1, 2, 3, 4, 5, still 7, roughly 10. Everybody else, definitely give it a look. It is an interesting concept. And I'm not going to talk about Akka anymore because it is actually more like a complete tool set and framework and allows you to implement the actor model, an application according to the actor model on the JVM, which is pretty cool. But that is not necessarily what you want at that point. What we really are looking for is something to handle that streaming approach even in existing applications. So that is why something called the Reactive Streams specification has been created. And I would need a lie at that point because I don't know when it was created, probably 3-4 years ago. Together with a bunch of big companies, including Red Hat and IBM, and obviously Lightbend has also been part of that. So a small introduction for Java developers is linked in the bottom here. Make definitely sure to check out the dev.lightbend.com tech hub. There are a lot of interesting articles even for Java developers. I know that Lightbend is known for Scala as one of the main languages. But I'm a Java guy, so I'll keep pointing you to Java references. So the Reactive Streams specification was agreed upon and created to have that standard for asynchronous stream processing on the JVM. And good news is Vertex implements it, Reactor implements it, and also Akka Streams implements it. So we can also find something called the Flow API in Java 9. Please don't get confused at that point because everything that is in the JDK is more or less the bare bones implementation plus the service provider interfaces. So what you really would need to do to work with that, you would need to implement all of that back pressure and all the SPIs yourself. So don't work with that and thinking it is a Reactive Streams library full capable of working with. But yes, you're right. This is all only inside of Akka Streams. This is all inside one JVM, right? So there is no integration aspect to it. And when we looked at the Java/Java E APIs, we also learned that we can't just pipe the existing APIs into each other without any drawbacks. So what we're really looking for is something that allows us to have that source, flow, sync concept over a synchronous boundary. So we need some kind of adapter concept to that. And that is definitely not covered by Alpakka streams themselves. What are real use cases for what I'm telling you? So where can you actually expect to run into that? It's pretty simple. First of all, we talked a lot about microservices. So number one use case, together with new business requirements, you will run into this probably with modernization projects. Whenever somebody says microservices, you start answering distributed systems, and you start thinking about how to connect those bits and pieces back together. So this is definitely one thing. Another thing where you can probably run into streams and asynchronous processing is ETL batch-style applications. So what you'll see out there is more like the classical Spark design with a job manager that persists everything, and the job control brings all the parts back together. But those architectures, moving them over into real-time and streaming approaches is probably the second best use case for streaming at the very moment. And you can actually use Alpakka streams here too, just to plant that as a little seed in the back of your head. Good news, if you want to learn more about moving ETL batch into a streaming world, this is something I'm not going to talk about today, but there's a free O'Reilly ebook by one of our VPs of fast data, that's what I like to call him, and he wrote this wonderful 80 pages book, I think it's just 80 pages, where you can get a really solid introduction how to actually work with fast data and asynchronous processing instead of batch and ETL applications. The slides will be available afterwards, I believe, so you can just pick them up and copy those URLs. So what's my use case here? The number one, the modernization kind of use case. So just imagine we have that brownfield little poor reactive microservice sitting next to another nice microservice, and those two can really neatly communicate and connect because everything's just working out of the box. But there's this legacy world, right? So how do I connect to my applications, to my existing applications? REST? Maybe. Asynchronous? Partly, depending on the library you're using and your ability to actually implement it right. Java message service. We've talked about queuing, we've talked about messaging. JMS might actually be a valid option to use. It is missing back pressure, though. So there's no real signaling of load behaviors of your individual services. JDBC, totally screwed, completely synchronous from top to bottom. They are thinking about putting an asynchronous API out, but I think it didn't even make it into a JEP yet, so we're still waiting for that. WebSockets are actually a good idea because bidirectional communication, but also no back pressure at that point. So we have no way to actually signal our new fancy, slick reactive microservices if they can still start producing data and overloading our legacy applications, or even the other way around. So that kind of flow control is missing over the boundaries. And the answer is, of course, as always, it depends. You can have all kinds of technologies in those mixed legacy projects where you strangle out some new functionality into your first service. And here's a very recent pointer. Martin Fowler actually blogged about or wrote an article about modernization and where to start decomposing your existing applications and where to go from there. So that's actually a good pointer. I should have put that in here. Just Google about modernization and Fowler and look for the latest article. So yeah, you can use all of these technologies, no worries. I'm not preaching, as always, software. I personally believe software and building applications requires one thing from all of us, and this is using the right thing for the right job instead of just using the hammer and trying to hammer in a screw or whatever. Always think about what you're actually picking. So, streaming back pressure. I'm taking a lot of pressure out of this presentation. Meet Alpakka. So, this is Alpakka. And I've never spoken to that guy here personally, but it's obviously a nice coworker of a camel on the other side of the world, which is also a comparably fancy integration library that you probably have heard about. But Alpakka is camel done right, done for streaming. I have to admit, we're not where camel is in terms of connectors right now. It's, 20-something at the very moment. But you should find one for the most precious use cases, especially those nice technologies like JDBC. Wait, JDBC? Didn't I say that is completely synchronous and screwed and can't be used? There's an example, and because I do want to give you some more homework, there's a GitHub repository in here too, so you can play around with that example because it's live out there. Let's assume I do have a fancy reactive microservice here, based on Akka, HTTP, presenting endpoints to the clients, might actually be a mobile app or whatever. We do have Akka Streams to do the heavy lifting, processing of stream-based information. And there's this fancy little H2, which is a synonym for literally every DB2 or Oracle database out there. It was just easier to stand it up with H2 in memory for the demo. And Alpakka actually takes two components here. First of all, a library called Slick that comes from the Scala world and gives you a synchronous JDBC access. You can simply use it as it is inside Alpakka, even without having to learn about Slick that much. And the Alpakka Slick connector, which is something that you are going to use. Bunch of Maven dependencies. I more or less often hear from people that all the examples from Akka and Alpakka are all Scala-based code, and it's really not convenient to use them. So I decided to bring up all my examples in Maven. You see a parameter in here which is called the Scala version. Don't be scared, it's an artifact ID. It's about binary compatibility. That's what we're signaling here, but you don't really need to use Scala. Don't get scared. All you need is Maven compile exec, and what you get is a fancy, nice little text field that is coupled to a WebSocket backend, and which actually streams database results out of the database. And if you execute that little more endpoint, you'll get another 50 results into the database, which are streamed into the database. Look at the code, it's fancy, and if you like what you've seen under the Alpakka JDBC project, you can also use the Alpakka SSE project. It's still missing documentation, but you should understand it when you see what you're looking through the main class. It's literally one main class to go through. And I do accept pull requests, so whoever has some time to help me doing that. What's the other big difference between Camel and Alpakka? The enterprise integration patterns. Camel has a vast implementation of all the enterprise integration patterns. This is where Camel actually started out as a library back in the days. What you can do, and this is just a simple example, you can, of course, implement all those integration patterns without problems in Akka Streams. So that's not a big thing to do, but it's not a prepackaged component that you can just reuse, right? So that's the only downside. I've been talking a lot about Java EE and legacy in that point. So what we did in Lightbend, we thought a little bit about how we can bring reactive streams and all the knowledge that we piled up over the last couple of years into the Java EE specification. So we decided to join the Jakarta EE working groups and help build a microservice profile and also help work with the existing applications, for example, Java EE servlets, to actually bring a streaming approach into upcoming Java EE, Jakarta EE versions. Again, some homework for you. A little bit of thoughts around how to improve existing APIs to be able to handle streaming data, and also some more background on why Lightbend is doing all of that, because as you can tell, Akka and Scala in general, the package is more or less suited for distributed computing. This is something that people use when they can't implement stuff in existing languages anymore. It's made for distributed computing. But we also want to make that available to the more broader audience and also make sure it integrates with existing applications. May the 4th, a little bit off, but anyway, may the sauce in this case be with you. Couple more links for you to dive into. Of course, the Akka page on lightbend.com. More importantly, Lightbend also sponsored an Alpakka team. That news came out just 2 days ago. So there will be commercial support around the Alpakka connectors, and we'll make a lot more available over time. So the community now has an official head. Official GitHub repositories, documentation, my example again. So what I didn't talk about, and it's kind of the most advanced question I got in my earlier talks about microservices at exactly the time where I decided to stop talking about what microservices are. The first question was, can you please explain what microservices are? So I stopped doing it. Instead, I keep pointing people to the Reactive Architecture book from Jonas Bonner. He's the co-founder, CTO of Lightbend. He's also the creator of Akka, so he wrote the first implementation of Akka back in the days. It's 80-something pages. It's free to download. Just register. I'm not going to send you a washing machine. Just get it. It's easy to read. And he wrote that book a couple of weeks before I actually joined Lightbend back in 2 years ago almost. And I said, well, my CTO gets to actually write a book and I don't. Yeah, that didn't take long for me to actually also write a book. And as a CTO, he has to talk about architecture. So I talked about implementing stuff. And instead of talking about Akka and how to do microservices bare bones, I used logom, which is the newest framework in the Lightbend family. It is meant for one thing, exactly one thing, to build a microservices-based application. So if you want to build a normal CRUD application, don't even look at logom. It doesn't make any sense. But if you really need to build a microservice-based system, this is where you want to look. And if you're even a little bit before that, and not even sure if you want to build something microservice, this is another free ebook that I wrote almost 2.5 years ago when that whole microservices trend really picked up. And it talks a little bit more about motivations and how to convince or argue with your boss for or against microservices. Also free, download, still outside, available. And that should have been it from a presentation side. I'm more than happy to take questions. I'll also be around for another couple of minutes. More than happy to answer. Yeah, let's go.
You mentioned applications doing invoicing.
Yeah.
Something in the batch job. Is it possible to transform it to the stream? For example, if you have to create the invoices once a week or something, I mean, this is the problem that can be moved from batching to streams.
So, can you move problems from batching to streams? Short answer, yes. Even shorter answer, this is what the Fast Data book was all about. So download, get registered, and talk to me afterwards. I have a longer answer for you. I'll be around. Thank you so much for your time. Enjoy your coffee, and follow me on Twitter. That's where all the latest news happen. My fear. Thank you.